Hello, everyone. It's good to be here with all of you today. I want to start with a confession about our profession. Most of our careers, the worst thing a broken data pipeline could do was embarrass us. A wrong number shows up on a dashboard, someone notices it in a Monday meeting, we trace it, we fix it, we move on. The data was wrong, but the human was always standing between the data and any real decision. That era is ending, and almost nobody has redesigned their data layer for what comes next. A quick word on who I am, and then we get into it. I'm Vishwak Thatikonda. I'm a senior architect and a developer with STH Systems, and I spend my days building large scale systems across retail, fintech, and financial services. The work behind this talk is enterprise master data, the systems that decide what a customer is, what a store is, what a product is across an entire company. I'm not going to read you my resume, I would rather earn your attention with the content. So let me make you a promise instead. Here's the promise. By the end of the next half hour, you will understand why the data layer most of us built, the one we designed for analytics, is the wrong foundation for AI agents that take action. You will walk out with 4 concrete design principles you can apply to your own architecture. And you will watch the failure happen in live, side by side with the fix. The title is From Analytics to Action. That shift from analytics to action is the whole ball game. Let me show you what I mean. Think about how our relationship with data has evolved in 3 acts. Act 1 was observe. We built dashboards. Data told us what happened yesterday. A human looked at it and drew a conclusion. Act 2 was recommend. The models got good enough to suggest. Here is the customer likely to churn. Here is the product to reorder. But a human still made the call. Act 3 is act. And this is not a forecast. It is already here. Agents are placing the reorder. Agents are issuing the retention offer. Agents are triggering the workflow directly with no human reviewing each decision. And here's the part that should make every architect in this room sit up. In Act 1 and Act 2, bad data produced bad information, and a human could catch it. In Act 3, bad data produces a bad action that has already happened by the time anyone looks. So the question becomes unavoidable. What breaks when we point an autonomous agent at a data layer that was never designed for this? The honest answer is almost everything, quietly. Look at what we actually built. Our data stacks were optimized for analytics, batch pipelines that run overnight, eventual consistency, because a report can wait a few minutes, fuzzy entity matching that is good enough for a quarterly rollup. Every one of those choices was correct for a human reading a report, and every one of them is dangerous for an agent taking an action. This is the gap. It is not that our data is bad, it is that our data layer is solving the wrong problem. It was built to inform a person. We are now asking it to govern a machine that acts. Stale records and unresolved entities used to produce a misleading chart. Now they trigger a live operational decision. Let me make that concrete with one that actually happened. I will keep it anonymized, but the shape is real. A replenishment agent at one of our retail deployments started placing duplicate orders across a whole cluster of stores. Nothing had shipped, no new code, no model change, nothing touched. The agent was behaving exactly as designed. The cause was upstream, and it was tiny. Someone improved an address normalization setup, a good change on its own, but it caused one store to resolve to two different golden records. And from the agent's point of view, two golden records means two stores. So it ordered opening inventory for both. Every order looked completely valid in isolation, which is exactly why nothing alarmed. It ran for 2 days. By the time we caught it, that was 9,400 duplicate orders and about $41,000. And here's the number that matters the most: zero lines of agent code were at fault. The agent did its job perfectly. The data lied to it. This is the whole thesis of the talk in one incident. An agent is only ever as trustworthy as the substrate underneath it. So let me name the ways that the substrate breaks. There are four failure modes I see again and again. One sentence on each because we are going to watch all of them happen live in a few minutes. The first is staleness. Your batch refresh means the agent is acting on a picture of the world that is sometimes hours or days old. It is making confident decisions about a reality that has already changed. The second is near match identity errors. Fuzzy matching that was perfectly fine for reporting now treats one entity as two, and the agent acts twice. The third is duplicate entities. When your golden record is not truly resolved, the agent fires conflicting actions against what it thinks are two different things, but are actually the same thing. The fourth is drift. Your schemas and your values drift slowly. No error is ever thrown, and your resolution accuracy quietly rots from the inside. Each of these maps to design principle that fixes it. Here are the four principles. If you remember nothing else from the architecture part of this talk, remember these four. Immutability. Stop overwriting records. Append. Keep the full history so you can always reconstruct exactly what the agent saw at the moment it decided. When something goes wrong, and it will, you need that lineage. Version contracts. Every point where an agent reads your data is an interface. And interfaces need contracts, schema, allowed values, freshness guarantees, all explicit, all versioned. Real-time resolution. Identity has to resolve in milliseconds, at the moment of the event, not overnight in a batch job. The agent cannot wait until tomorrow to know who it is talking to. And the fourth one is event-driven execution. State changes have to flow reliably the instant they happen. Put those four together and you get something our analytic stacks never had to be. A substrate an agent can trust at the moment it acts, not just at the moment someone runs a query. Now let me ground this in something real. I want to put a number on the room that we're operating in. The work behind the stock is a master data platform for a global retailer with roughly 38,000 locations, or maybe a lot more at this point. I do this through SDH systems, and at that scale, you stop thinking about master data as a reporting asset that lives in a warehouse, and you start treating it as a live operational layer that the business runs on in real time. The constraints are unforgiving. Tens of thousands of locations, a target of resolving an entity end to end in under 200 milliseconds, and an absolute requirement that every agent an action takes happens exactly once, no matter how many times the underlying event gets delivered. Those numbers, 38,000, sub 200 millisecond, and exactly once, are the entire engineering problem in a nutshell. Let me show you how exactly the resolution works under that kind of pressure. This is the heart of it. The pipeline is ingest, normalize, match, score, publish. And the whole round trip has to fit inside that latency budget. A few things that make it trustworthy, not just fast. We use deterministic keys. The same real world entity always computes to the same key, which means restarts, replays, and re-ingestion never accidentally create a second copy of it. We score probabilistically, but we surface the confidence. The agent does not just get an answer, it gets how sure we are. High confidence, it acts. Borderline, it holds. That honesty is the difference between an agent that is safe and an agent that is merely confident. And the survive rules. The logic that decides which value wins when sources disagree live in version controlled code, sitting right next to the data contracts, not buried in some pipeline config that nobody can find. The result is simple to state. The agent gets one trusted entity, fast, with the confidence it can actually reason about. I said resolution has to happen in milliseconds. Let me open the hood on how, because the how is where the real engineering lives. The naive way is to resolve identity, is to compare each incoming record against every record that you already have. That is fine for 1,000 records. At our scale, it is billions of comparisons per event, and you will never see 200 milliseconds again. The trick that makes it possible is blocking. Before any expensive comparison, you generate a small candidate set. The handful of records this one could plausibly match using cheap blocking keys. You turn a billion comparisons into about 5. Blocking is the unglamorous thing that makes real-time resolution physically possible. And it is the part most teams skip. Once you have candidates, the matching combines signals, name similarity, address geometry, geographic distance, contact fields, each weighted. And the whole thing is explainable. So you can defend why 2 records merged. And the output is not a yes or a no. It is a confidence band. Above a high floor, auto merge. Below a low floor, treat as separate. In between, do not guess, route to a human. The agent is always told which band it is standing in. That is resolution under the hood. Now, the services it runs on. Now, quickly, the building blocks, because this room knows these services and I do not need to sell them. Lambda for the resolution itself. Stateless, event triggered, scales with the firehose, and critically, it reruns safely when an event is retried. DynamoDB as the golden record store. Single digit millisecond reads and its change streams are the backbone of our change data capture. Event Bridge as a nervous system, a schema registered bus that routes the right entity changes to the right agents. None of these are exotic. The architecture is the point, not the logos. Now I want to talk about the part everyone underestimates until it burns them. What happens when the same event shows up twice? In an event-driven system at scale, this is not an edge case. It is a guarantee. Networks retry, queues redeliver. The same event will arrive more than once, every single day. Idempotency means that no matter how many times an event fires, the outcome is the same as if it had fired once. Now, here why this matters in Act 3. When the consumer was a dashboard, a duplicate event was a rounding error. When the consumer is an agent, a duplicate event is a second payment, a second shipment, a reward redeemed twice. The duplicate does not corrupt a number. It takes a real action in the real world. We enforce it in three places. Deterministic request IDs at the moment the event is born. Conditional writes in DynamoDB that physically refuse to commit the same transition twice. And deduplication windows on the bus itself. I will say this as plainly as I can. Idempotency is the difference between shipping one order and shipping three. So once you have a trusted entity change, it needs to reach everyone who cares about it, without you wiring point-to-point spaghetti between every service. So we publish it once to the bus. The inventory agent subscribes, the orchestration layer subscribes, the reward engine subscribes. Nobody pulls the golden record store, and nobody calls anybody directly. Two things fall out of this that you really want. Contracts get enforced at the routing layer, so a malformed change never reaches a subscriber, and failures land in a dead letter queue, which means you can replay them, and you can reconstruct exactly the sequence of events the agent saw when it made a decision. That replay capability is worth its weight in gold. The first time you have to debug an agent's behavior in production. But even with all of this in place, there is one thing that degrades so slowly you will not notice until it has already cost you. Drift. Drift is a silent killer of agentic systems because nothing breaks, no alarm goes off. The pipeline is green, and yet your match quality is decaying 0.1% at a time, until one day the agent is acting on entities that are subtly, consistently wrong. You fight it by making it visible. Three ways. You define drift thresholds, match confidence, field completeness, record age, and you alert the moment they move. You profile continuously. You watch the entity streams for schema shifts and distribution shifts in real time instead of finding out at the end of the next audit. And you control the loop with the agents themselves. When an agent's confidence drops, that is a signal. Feed it back into the hub as a correction. The principle underneath all three is the oldest one in operations. You cannot fix what you cannot see. So make drift something you can see. And making it visible means instrumentation. So here is the dashboard you actually watch when this is running in production. 4 things. The first one being resolution latency. P50 and P99 against your 200 millisecond budget. Watch the P99, not the average. The average will lie to you. The P99 is the one that wakes you up at night. Match quality being the second one. Precision and recall, measured continuously against the labeled sample. The moment the precision drops, the moment the precision dips, your agent is about to start acting on bad merges. And you want to know before it does, not after. The third one being contract health. The rejection rate and the dead letter depth per minute. A sudden spike there is almost always an upstream producer that just broke its schema. You catch it at the bus before a single agent sees the bad data. The last one being drift and recovery. the confidence distribution, the record age, the idempotency rejections per hour, and the replay success rate, which is the metric that proves you can actually recover when something does go wrong. All of this rests on one thing being stable underneath it: the contract. This brings together everything we've talked about: the data contract. Every agent binds to a version contract. It specifies the schema, the allowed values, the freshness guarantee it can rely on. If you want to make a breaking change, you publish a new version. You do not silently mutate the one that is live. And any record that violates the contract is rejected before it ever reaches an agent. The mental model I want to leave you with is this: treat your data contract exactly like you treat an API contract. You would never let a service silently change its API shape on consumers in production. Stop letting your data do it. Version it. Enforce it at the bus and put a name on it, an owner and a steward, so there is a human accountable for that contract. Not just a table anyone and everyone uses and no one knows. Now, contracts and the four guards stop the failures we can name in advance, but a serious system also plans for the failure it did not predict. So before the demo, one more layer: what happens when the agent is wrong anyway? Everything so far has been about preventing bad actions at the level of a single event. But you design a safe system assuming that one day something gets through anyway. So you add a second kind of defense, one that limits the blast radius of any single mistake. Four controls. The first one being a circuit breaker. These do not look at any one event, they watch the aggregate. If the rate of anomalies or low confidence decisions suddenly spikes, the breaker trips and pauses the agent, even though every individual event looked fine. That is the one that saves you from a bad batch. Human in the loop. Above a certain impact or a certain uncertainty, that action does not execute. It escalates to a person. You decide where that line sits, but you draw it deliberately. A kill switch. One control that halts an agent or a whole workflow instantly and preserves state, so you can replay cleanly once you have found the cause. And blast radius limits, rate caps, segment fences, hard ceilings on how much any single decision is allowed to touch, so a bug stays an incident instead of becoming a catastrophe. Now let me show you all of it: the failures, the guards, and that last line of defense live. So before I run anything, let me orient you. One event stream, two systems. On the left, legacy MDM, last write wins, fuzzy matching, the way most master data is built today. On the right, the action grade design we just walked through. The same autonomous agent sits on top of both and acts on whatever each one resolves. So let's move on and see our first event. So the first event is a clean baseline on purpose, so you can see what normal looks like. A brand new store comes online, both lanes do exactly the right thing, a golden record is created, and the agent allocates opening inventory. No drama. The one quiet difference is on the right. The action grade lane mints a deterministic key for this store right now. Hold that thought. It pays off in about 3 seconds. Now the same physical store comes back, but under a different ID, messier address. Watch the left lane. Legacy's fuzzy matched scores it just under the line, decides this is a brand new store, and ships a full opening inventory order a second time. That is $18,000 of inventory and freight gone, and nobody flagged it. Now on the right, the same messy record resolves to the same deterministic key we minted a moment ago. So it merges into one record, no duplicate, no second shipment. Moving on to the next event. So this is the failure mode everybody underestimates. A loyalty reward gets retried by the message bus. Same event delivered twice. Legacy has no idempotency. So it reprocesses the key, reprocesses the retry, and credits the member 500 stars a second time. On the right, the lane checks the event ID against its commit log, sees the event is already there, and the conditional write simply refuses. That line is the actual guard. Put if not exists, rejected, exactly once holds. The agent physically cannot act twice. Moving on to the next event, out of order delivery, which is completely normal at scale. An old inventory snapshot version 3 shows up after version 5 was already committed. Legacy is last write wins. So the stale v3 overwrites good data. The agent reads 0 on the other hand and fires off an emergency restock the store never needed. The version contract on the right requires writes to move forward. v3 is older than v5, so it refused, and the agent never even sees the stale state. Now, in this event, there's two different customers, similar names, same city. The matcher scores them 0.7. Excuse me. So it auto merges the two strangers and hands one person's elite perks to the other. That is a privacy incident, not just a cost. The action grade lane on the right treats matching as a confidence band, not a single line. 0.71 lands in the uncertain zone, below the auto merge floor. So instead of acting, it routes the pair to a human for review. The agent only acts on identity it can actually trust. Last of the per event cases. An upstream service pushes a record using an old schema, missing a required field. Legacy ingests the partial record as is. The agent reads a null status, assumes the store is open, and routes a shipment to a location that is actually closed. On the right hand side, the record fails validation against the registered contract, gets rejected at the bus, and lands in the dead letter queue. It is replayable once the producer is fixed, but no bad data ever reaches the agent. Alright, now the final event. This is the safety net from the previous slide, made real. A bad upstream batch misfires and fires a burst of low confidence merge requests, 120 of them in a few seconds. Watch the left. Legacy has no concept of rate. It auto merges across the entire burst. The agent acts on everyone and the number explodes. That is the unbounded blast radius. And on the right hand side, each merge would route to review, but the rate itself is the alarm. This, the circuit breaker crosses its threshold, trips, and pauses the agent. The whole backlog is held for human review. Zero actions taken. Now let's watch it all once again. Alright, that was the demo. Back to the presentation now. Now that we've gone through the presentation, let me give you a roadmap for doing this right. But before that, let me save you some time by naming the 3 ways I most often see teams get it wrong. All 3 feel like reasonable shortcuts. The first is a cache mirage. You put a fast read cache in front of your batch warehouse and you call it real time. But it is not real time. It is fast access to stale truth. And that is actually worse than slow access to stale truth, because now the agent trusts it completely. The second is treating this as a cleanup project, one time data quality scrub with a start date and an end date. But drift never stops. The day you declare victory is the day it starts decaying again. This is a living service, not a project. The third is the overmerge. Teams get seduced by the idea of one perfect golden record, and they merge too aggressively. Remember the demo? For an agent that acts, a false merge is more dangerous than an honest duplicate. When in doubt, do not merge. Avoid those 3 and you're most of the way there. So here's the right way to do it in phases. So how do you actually get from where you are to where that right lane is? You do not boil the ocean, you go in 4 phases. Phase 1 is assess. Audit your current master data for latency, for drift, for identity gaps, and find the touch points where an agent is already acting, because that is where your risk is concentrated. Start there. Phase 2, harden. Bring in immutable records, deterministic keys, and idempotency, but only on your most critical entity domains first. Phase 3, stream. Replace the batch pipelines with event-driven change data capture and put your contracts on the bus. Phase 4, operate. Stand up the drift monitoring, the agent feedback loops, the contract versioning. This is where master data stops being a project and becomes a living service. The thing I want you to hear in this is permission to start small. You do not need to rebuild everything. You need to start with the entities your agents already touch. Now let me leave you with 3 things. If you forget the diagrams, keep these. 1. Assume your agents will act, not advise. Design your data layer for the moment of execution, not the moment of a query. 2. Immutability and idempotency are not optional anymore. In a world of guaranteed retries and redelivery, they are the difference between a system that is correct and one that is merely usually correct. 3. Your data contracts are your agent's APIs. Version them, enforce them, own them. And here is a sentence I would write on the wall. The data layer is no longer behind the AI. It is the thing that decides whether the AI is safe to act at all. This is what I have for you. Thank you, all of you, and thank you to the organizers for having me here today. If any of this was useful, or if you want to argue with me about it, I would genuinely love that. You can find me on Twitter, LinkedIn, and I will also leave my email. And I will be around for the rest of the day if you want to talk to me or have any questions for me. And if anyone wants to watch that demo, break something one more time, I'm more than happy to share it with you. But yeah, thank you, everybody.